Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
In supercomputing, the grand challenge is a problem that traverses the frontiers of the fields of mathematics, physics, and computer science. The grand challenge is a problem such as global warming that is defined by the public, or a question that society wants to be answered now. In my supercomputing quest for how to solve the grand challenge problem, I discovered how to lift calculus out of the blackboard and into the motherboard and across a new internet that I visualized as a new global network of processors that is a new computer de facto. I discovered how to lift calculus out of the mathematics textbook or the WAEC and JAMB examinations, and how to put calculus into the mile-deep oil fields that each occupy the space of a town in the Niger Delta region of southeastern Nigeria. As a research supercomputer scientist, I see myself as a hunter or a predator, and my prey is the unknown. My quest is to know something nobody else knows. Back in 1989, the foremost vector supercomputer scientists couldn't understand how I parallel processed across a new internet that is a new global network of 65,536 tightly coupled and identical processors. They couldn't understand how I was able to harness that new internet and use that new technology to record the highest speed increase of a factor of 65,536 and record the fastest supercomputer speed that made the news headlines. At first, my massively parallel processed supercomputer experimental results of the 4th of July was rejected as a quote-unquote terrible mistake. After 2 months of rejections, and on September 1, 1989, I took my discovery of practical parallel supercomputing to a 15-day hands-on vector supercomputing workshop that took place in the largest national laboratory in the Midwest region of the United States. That national lab was in Chicago, Illinois. I was invited to Chicago because the parallel supercomputer could become the enabling technology that must be harnessed when applying the computation-intensive mathematical physics that must be used to foresee natural hazards that threaten lives and livelihoods, as well as foresee long-term hazards such as global warming that threatens the health of planet Earth. The parallel supercomputer is the vital technology that must be used to supply timely, relevant, and useful information about the global motions of the fluids that enshroud planet Earth. The extraordinary importance of that supercomputer hopeful was the reason I was invited to the supercomputer workshop that was sponsored by the United States Department of Energy and that was held in the 15 days inclusive of September 1 to 15, 1989. On my first day at that supercomputer workshop, I was mocked and ridiculed because I claimed that I could parallel process across a new internet, that is a new global network of 65,536 commodity processors that were identical to each other. I was offhandedly dismissed because I also claimed that I recorded the highest parallel processed speed increase. I recorded the fastest supercomputer speed in 1989, and I did so when everybody said that my speed was impossible to attain across the slowest processors in the world. But as that supercomputer workshop progressed, the supercomputer instructors learned that I had been supercomputing since June 20, 1974 in Corvallis, Oregon. They learned that I knew more about the parallel supercomputer than any supercomputer scientist knew. At that workshop, I gained credibility as an expert in parallel supercomputing. With each day that passed, I noticed that I was getting fewer and fewer mockeries of my parallel supercomputer discovery. By the 15th and last day of that supercomputer workshop, the majority of the attendees became convinced that I had achieved a breakthrough in parallel supercomputing. Yet, the few naysayers at that 15-day workshop taunted me to submit my parallel supercomputer calculations to the 4 supercomputer scientists and judges that award the top prize in the field of supercomputing. 5 months later, one of those naysayers called to congratulate me after he read the story about the African supercomputer genius that won top US prize. In retrospect, the rejections of my proof of principle of 1989 and of my experimental discovery of proof of principle of 1982 and of my experimental discovery of 1989 of the parallel supercomputer gave me street cred as the inventor of practical parallel supercomputing. I presented my proof of principle in November 1982, and I did so at a conference auditorium that was a short walk from the White House in Washington, D.C. The rejection that occurred on July 4, 1989, of my discovery of practical parallel supercomputing proved that I invented a new technology that was vital to the computer and to the supercomputer. Parallel supercomputing was first theorized in print as science fiction back on February 1, 1922. Practical parallel supercomputing was born in Los Alamos, New Mexico, United States, and entered into computer textbooks as non-fiction and did so after I discovered it. On July 4, 1989. It was at the International Computer Conference that took place on February 28, 1990 at the then Cathedral Hill Hotel in San Francisco, California, that practical parallel supercomputing was officially upgraded from science fiction to reality. At that computer conference, I was given the top prize in the field of supercomputing, and I was recognized for my contributions to the development of the computer. My contribution is this: I upgraded the parallel supercomputer from science fiction to reality. The rejections that I received proves one important thing, namely, parallel supercomputing was not obvious to the leading supercomputer scientists of 1989 and earlier. The idea of parallel supercomputing first came in print back on February 1, 1922. But practical parallel supercomputing remained a grand challenge until I discovered the technology 67 years later and discovered the technology across a new internet that is a new global network of commodity off-the-shelf processors, and discovered the technology on my eureka moment of 8:15 in the morning of July 4, 1989 in Los Alamos, New Mexico, United States. When I began my quest for the fastest supercomputer technology, I didn't have a supercomputer per se. I used a parallel processing ensemble that's a new internet de facto, and that's defined and outlined by 65,536 central processing units that were equal distances apart from each other and that shared nothing between each other. The supercomputer community of 1989 knew that each of my central processing units could only execute 47,303 calculations per second. That was the maximum sustained speed that I attained for the specific grand challenge problem that I was tasked to solve. In 1989, the leading minds in the world of supercomputer, such as Gene Amdahl and Seymour Cray, insisted that it will forever remain impossible to divide a grand challenge problem into smaller problems and then to parallel process that grand challenge problem and solve it across the slowest processors in the world and solve that grand challenge problem at the world's fastest supercomputer speed. In 1989, I was in the news headlines because I received the top prize in the field of supercomputing, and because the supercomputing community deduced that I integrated 47,303 calculations per second per central processing unit, and that I integrated those calculations across my new internet that is a new global network of 65,536 central processing units. My supercomputer experiment of July 4, 1989, that made the news headlines enabled me to reach the total supercomputing speed of 3.1 billion calculations per second. That was the fastest speed on record for solving grand challenge problems. That supercomputer calculation made the news headlines as a world record and was recorded in the June 20, 1990 issue of the Wall Street Journal. As a black supercomputer scientist that was born in Nigeria, Africa, I did not have the structural advantages that put Seymour Cray or Steve Jobs in their leadership positions and that made it possible for them to claim the credit for other inventors' inventions. In the past, it was a tradition in American science to reassign the credit for the invention of a black slave to his white owner. So it should not come as a surprise for me to say that vestiges from the past carried over to the present and that I was blackmailed and threatened to reassign the credit for my inventions to white non-inventors who could not give a public lecture on my inventions and who've known me for 7 years but yet could not even spell or pronounce my last name. Recently, Seymour Cray, the pioneer of vector supercomputers of the 1970s, was reassigned the credit for inventing the massively parallel supercomputer. Yet, it is well documented that Seymour Cray ridiculed, mocked, and dismissed the parallel supercomputer as a huge waste of everybody's time. In the 1980s, Seymour Cray taunted aspiring parallel supercomputer scientists and did so by asking them, quote, "If you were plowing a field, which would you rather use? 2 strong oxen or 1,024 chickens?" Unquote. Looking back to the 1980s, some scientists that fought to get the credit for my invention of practical parallel supercomputing were very self-regarding scientists and arrogant men with a strong sense of self-entitlement to getting undeserved credits. Some scientists were asked to apologize to Philip Emeagwali for plagiarizing, stealing, and publishing his inventions as their inventions. I'm Philip Emeagwali. The grand challenge problems of supercomputing are the toughest problems arising in mathematical physics. The modern supercomputer is an instrument that must be used to solve the toughest problems, such as general circulation modeling, to foresee otherwise unforeseeable climate changes. In 1989, I was in the news headlines because I discovered how to solve grand challenge problems and how to do so by dividing each problem into 1,000,000 smaller problems and then parallel supercomputing them at lightning fast speeds and across as many processors. I was in the news headlines because I discovered how to solve once impossible problems and how to solve them across a new internet that is a new ensemble of 1,000,000 processors that represents the as many brains of a new virtual supercomputer. What sets the new supercomputer apart from the old computer are these. The new supercomputer occupies the space of a soccer field. The new supercomputer have the combined speed of 1,000,000 processors. In essence, my supercomputer is built from the same processor that your computer was built from. The crucial difference between a supercomputer and a computer is that the 1,000,000 processors inside that supercomputer are integrated to become one seamless, cohesive virtual computer that is super, beyond super. This new supercomputer technology called parallel processing made the news headlines when I discovered it on the 4th of July 1989 and discovered it across an ensemble of 64 binary thousand processors that were identical to each other, that were tightly coupled to each other, and that shared nothing between each other. A massively parallel supercomputer that must be used to solve the toughest problem costs up to $1.25 billion and occupies the space of a soccer field and must be chilled to prevent its millions of processors or brains from overheating. In the 1970s and 80s, and since February 1, 1922, parallel supercomputing was on the drawing board. I worked alone on practical parallel supercomputing, and I did so at the time the technology was mocked, ridiculed, and dismissed as a huge waste of everybody's time. For 67 years, practical parallel supercomputing was a formidable foe of mathematicians and physicists. A teacher asked her students, "What is Philip Emeagwali noted for?" My answer is this: I invented practical parallel supercomputing, the vital technology inside today's supercomputers. Until 1989, using the parallel supercomputer to solve a grand challenge problem remained in the realm of science fiction. Consider this: at a parallel processed supercomputer speed of 1,000 million billion calculations per second, it would take a person performing one calculation per second 31.75 billion years, or nearly twice the age of the universe, to solve a grand challenge problem that would take that supercomputer only 1 second to solve. Parallel processing revolutionized the way we think about the fastest supercomputers that must solve millions of problems at once, instead of solving a grand challenge problem and solving it in the step-by-step serial processing fashion that was the prevailing paradigm since the programmable computer was invented back in 1946. The parallel supercomputer is a technological revelation that is standing the test of time. The parallel supercomputer is a critical technology that makes the impossible to compute possible to compute. For that reason, the stake on the new supercomputer was so high that the United States added a Russian supercomputer maker to its list of nuclear threats. It's a crime for a US company to sell a supercomputer to a quote-unquote unfriendly nation. In China, it's also a crime to export Chinese supercomputer technology to the United States. In Japan, it's also a crime for me, Philip Emeagwali, who is a non-Japanese, to browse through the operating instructions of supercomputers that were made in Japan, even though I invented practical parallel processing as the vital technology that underpins every supercomputer that is made in Japan. It's a crime to export US supercomputers because the parallel supercomputer is de facto a weapon of mass destruction. The fastest supercomputer provides the horsepower for secretly simulating nuclear explosions and doing so in parallel and across an ensemble of millions of commodity off-the-shelf processors that were tightly coupled to each other and that shared nothing between each other. That was the reason the United States government classified the parallel processed solution of initial boundary value problems to be grand challenge problems. After all, solving this once impossible problem transcends abstract mathematics. The solution of the grand challenge problem of mathematical physics is a positive contribution to human progress. Thank you. I'm Philip Emeagwali.
Insightful and brilliant lecture. Insightful and brilliant lecture.